Hundreds of buildings constructed throughout the Northwest have a hidden advantage. Their designs have been tested and perfected by a University of Washington lab where commercial architecture and engineering meet the science of energy efficiency.
We're helping develop conservation as a primary source of energy in the future. Essentially, we're trying to substantially reduce the amount of energy that commercial buildings use, and therefore reduce the amount of power that we have to generate in the region.
The Integrated Design Lab, or IDL, is known for its innovative research into building designs with built-in energy efficiency. The lab tests architectural and engineering models, suggests energy-saving yet cost-effective options. Then, after construction, the lab measures the operational value of the IDL recommendations.
The critical component of any good design process is setting early design goals, be they energy or lighting or cost, and then testing for performance in terms of meeting those goals throughout the design, construction, and operations process.
One of the IDL's claims to fame is its testing and research into the energy-saving value of daylight in built environments.
Lighting in commercial buildings consumes roughly 25% of the electrical energy used, or maybe the total energy used in a commercial office building. Being able to turn the lights off is the key component of highly energy efficient commercial buildings. That means good access to daylight.
And it'll move with the model.
The IDL's daylighting lab measures how a building's design and location affect lighting, cooling, and heating requirements. Here, the heliodon emulates the Earth's rotation relative to the sun. Researchers select the latitude of the building site, set the time of year, then rotate architectural models through hours of the day, measuring the angle and the movement of sunlight through a building's interior.
And we measure the brightness in the sky here.
The lab also recreates the overcast skies of the Pacific Northwest. Light sensors measure the difference between overall ambient light and the percentage of light reaching the inside of a building.
So if we can turn the lights off, reduce the cooling load, keep the sun out of the buildings, then we can actually almost eliminate cooling in buildings and take that capital and reinvest it in other energy efficiency measures that will reduce the heating that we put in our buildings, which is the dominant way we use energy.
Although much of this work is now modeled on computers, the Daylighting Lab helped create those computer programs and break new ground in energy-efficient designs for commercial buildings. And many of the designs percolating from the Integrated Design Lab are old ideas, now considered state-of-the-art.
Funny enough, state-of-the-art ideas 60 years ago. Buildings that use daylight, buildings that are thin, buildings that have operable windows.
The impact of the lab's research and testing is easy to find. The architects and engineers of the Terry Avenue office building used the IDL's services to design an award-winning space.
It was one of the first buildings of its type with great daylighting, and it was the first office building built in Seattle without air conditioning since the late 1950s.
And the newest tower at the UW Medical Center incorporates the latest innovations by IDL researchers.
And what we found out was that the largest energy use in a hospital is for heating. More than 60% of its energy is used for heating, and yet it consumes enough energy internally, and most of that energy is turned into heat, that it shouldn't need heat until it gets below 20 degrees outside. So it was sort of like, Houston, we have some sort of a problem here.
The lab developed strategies to construct hospitals that are 50% more efficient at no additional cost. And the applications for the IDL's research are not just regional. The lab is now working with medical centers in the nation's 5 largest cities.
I think what we've done regionally is, one, build a bridge between academic research and practice. And in architecture, that always isn't as connected as it should be.
We also educate these folks so that they can export this as a skill around the country. We've worked on over 600 buildings since 1999 in the Pacific Northwest, and we're completing roughly 2 million square feet of construction every year. It's a really great and exciting time.